Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? All right, good. Warm-up number 29 is on the screen. Shouldn't take you long. Get cracking. Go. You need the warm-up? Oh, okay. No, you're good. This is being recorded. Jackson said he wants to use his Chromebook for the warm-up. Okay. Oh, what's that? Oh, yeah. Yeah. But I said no Chromebook because we got this warm-up without any technology. Woo! Let's go. Well, actually, they can. Yes. All right. Here we go. We should be just about done with that warm-up. Let's see. I wonder who's going to get us started. Oh, hold on. Let's go with Citlali. All right, Citlali. What was your GCF for 24 and 60? 4. Close. It is. 6 is closer. 8 is not close. Correct answer is 12. 12 times 2, 12 times 5. Therefore, our giant 1 is 12, and we're left with 2 over 5. Oh, it's frozen? Okay. Let it go. Let it go. Have you heard that song, Jackson? Okay. All right. Number 1B. How do we factor the numerator? Citlali, pass someone. Jackson, how do we write this in factored form? 5 times C times C times C. All right, not bad. Denominator, what is the GCF? 5 and T. All right, and that leaves us with 2T plus 3. That is correct. Therefore, do you see any giant ones? Yes, 5 over 5, T over T. That leaves us in the numerator with 2 T's, or T times T is T squared. Denominator, 2T plus 3. Now, look up to the screen. Now, some of you might be tempted, look up, to do another giant one with these T's right here. But the only reason we can't is because we can't do that whenever there's addition right next to one of the factors or one of the numbers. Therefore, I cannot do that here. I could do that over here because when they're side by side, it's multiplication. Therefore, there you go. Number 2, factors for number 2. Share with your neighbor what you got. And Jackson's going to pass it to someone. Factors for number 2. All right, Jackson, pass someone. Factors. You do the Power Ranger thingy? Yes. Negative 18 on top. Very good. 7 on the bottom. So what 2 factors multiply give me negative 18 when you add them give us 7? Okay. So you can subtract gives us 7, but one of them has to be negative. Woo-wee. So this is x plus 9, x minus 2. Hands, have you got that? Let's go. We got this. We need 2 factors for number 3. Share with your neighbor what you got for number 3. Then Sam's going to pass it to someone. We got to go. All right, Sam, pass someone. Oh, do the x. What goes on top? Which is 12 and 7 in the bottom. Okay, what two factors of 12 give us 7? 3 and 4. Okay. However, we have a 6. What do we do with that 6 on top of these two? All right. Question, can I reduce this to lower terms? It's 2 over 1, therefore 2x plus 1. Can I reduce this one to lower terms? And that is what? Three over 2. Very good. So this is 3x plus 2. Hands, have you got that? All right. Not bad, not bad. Let's go to number 4. Let me make some space here. All right. So you guys know how to solve this by now, so I need an equation. So take your talk to your neighbor, see what that is, and Isaiah's going to pass someone. Y equals what? What is that equation? Talk with your neighbor. What is that equation? All right. Isaiah, pass someone. Brian. Y equals? Oh, I thought you had gone to the YouTube channel to watch the video lessons. Ooh. I mean at home when you're not here. Yeah. Yeah. All right. Then help us with this one. Layer. All right. So we need to leave Y by itself. So what do? What's that? Adrian, what do? That'll be the last step. Before that, we need to get rid of negative 12x. Yes, add 12x, add 12x. We end up with, yes? Negative 3y equals 12x minus 9. And then, where was I? Who's helping me? Oh, Adrian. Last step. Divide by negative 3, divide by negative 3. And then we end up with y equals negative 4x plus 3. And have you got that? All right. So then, now that we have our equation, we write it 3 times, but without the x. Why 3 times without the x, Mr. Q? Because the domain, or the x values that they give us, is negative 1, 0, and 1. Therefore, say here what you got for the 3 of them once you evaluate. Y equals what? Once you substitute that value in there, then Adrian's going to pass it to someone. All right, good conversation. So Adrian, pass someone. You add the 3 to. We got negative 4 times negative 1 is plus 3. Negative 4 times 0 plus 3. Negative 4 times 1 plus 3. Let's go. Hands, have you got that? All right. And that's how you evaluate. Let's go to number 5. Last one. Here we go. Mr. Q. All right, let me go over this one more time. Here it goes. What is GCF between 15 and 6, guys? 3. So this can be written as 3 times 5, and this one as 3 times 2. I need to rewrite these two. Bring down the 2, bring down the 5. So, question. What does this denominator have that this one needs? The 5. So multiply times 5, top and bottom. Next, what does this one have now that this one needs in order for it to look the same? The 2. So times 2 times 2. So let's rewrite these two fractions now with a common denominator. 3 times 5 is 15 times 2, that's 30. So both of them would be 30. 2 times 2 is 4. 5 times 5 is 25. Common denominator 30. Focus on the numerator. Aww. That's 29. Sam, you got that? Yeah? All right. Copy the agenda. Warm-up number 29. Today we're moving on to simplifying rational expressions. Tonight's home play sheet 10.3, all only. Oh, I haven't opened the assignment from last night. Let's go. Come on, Q. Pick up the pace. Oh, I'm about to send progress reports home. FYI, BTW. Is it still being recorded? Oh, yeah, it's being recorded. Oh, yeah. Actually, is it ticking? Yes. Oh, yeah. All right, go to the canvas, turn in your home plate from last night, 7 problems only. And just to give you guys some props, since you did your home plate, I'm counting this one as a pop party. Let's go. It's from the corner. Let's go. Ooh, that sounds like a good idea. Val for Presidente. It counts as a pop. Oh, you don't want me to count it as a pop party? Okay. All right. So copy the code as you're turning yourself in. LYCWG. LYCWG. That gives you access to the play sheet for tonight. Okay. LYCWG. All right. Last night's home play were these 7. Tonight's home play. Woo. Let's go. Fractions with polynomials. Let's go. I did it. I'm telling you guys. All right, got a Cornell note ready, please. You do need a fair model. Pick up the pace. We need to finish up. The square. Oh, the code again. Let me go back. LYCWG. 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 Yes, I was here in the morning for tutoring again. Anyone that wants to come in for tutoring, what do we do in tutoring? I help with the home play. Yes, Isaiah. You're going to be doing that over the weekend so you can study well. And then next week, just bring it in. All right, so the question was from one of your colleagues, those of you that are following on YouTube, is that, Mr. Q, for those of you that want to retake the assessment from last week, the quarter assessment, what do I need to do? Go to YouTube to the lesson titled Synthetic Division. In there you get the Nearpod code. it's going to give you access to the study guide. You're going to do the study guide on a paper completely. Get it signed by your parents. Bring that in. That's your ticket to take the retake. Because it's worth half your grade, so you still have time. Just give me a heads up. And once again, reminder, I'm here in the mornings and the afternoons. I sit till like 5. Yes. Yeah. That's why you have the weekend, hopefully, to actually study and retake. Yeah. You can come see me. Yeah. The whole thing. Yeah. It's not the same thing. I'm giving you a brand new one. Oh, yeah, I got this. All right. So before we get started with the session, really quick, in passing, I just want to make sure, because I keep hearing from Mr. Apodaca in the morning, and he reminded me. He said that, make your day be productive, number one. And number two, make you be the person that are being nice. Now, for those of you that don't know about my motto in the classroom, a student of mine even made me a sign over there underneath the Darth Vader sign. They went home and they carved it with a pen, and it says, be nice or leave, even though it's like an oxymoron, but you guys get the idea, right? That's why I even have in my poster reminder, rule number 1, respect everyone and everything in the class. Yeah, me, guys, I'm going to be telling you, like, next week I'm going to stop the lesson, I'm going to tell you a story, but I don't do well with bullies at all. No. At all. So in school, since I was in elementary, guys, to tell you the truth, I mean, I was like a solo person. I flew solo. Why? Because I didn't like people just like, treating people different because of whatever. And that's why I'm the way I am, I guess. Believe it or not, there's people, colleagues of mine that maybe they don't like me. Whatever. You know what I'm saying? It's one of those, like, you got to be you. Be you and let other people be them. But you can't be like, you know what I'm saying, just overpowering people because you want to overpower people. Especially when I was in football, oh my goodness, I couldn't stand some of the players, man. Man, there's some bullies out there. Not saying here, I'm saying when I was in school. So I'm just trying to remind everybody, rule number 1, respect everyone and everything. We good? Yes, Mr. Q. All right, let's move on. I can simplify rational expressions. Let's get started. I can simplify rational expressions. Tell your neighbor the main idea or the main concept we're moving on to now. What is the main concept? Yes, rational expressions. That is correct. All right, so at this point, we don't need our Chromebooks anymore. It's going to go a little fast. So everybody go like this. Bear with me. All right. You need to turn a little bit more? Oh, yeah, at the end. You'll do that at the end. All right, here we go. Rational expressions, what are they? They are algebraic expressions whose numerator and denominator are polynomials. Algebraic expressions whose numerator and denominator are polynomials. Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Adrian, you're right over there? Okay. Now, notice here, they don't mention something, but they're insinuating something by saying numerator and denominator. Tell your neighbor what they're insinuating, or what are they suggesting there. R2 in the house. Let's go. Yes, fractions. Whenever you hear the numerator and denominator, they're insinuating fractions. Here they are. 6 over g plus 4, 2x plus 1 over x squared minus 15x, 2x plus 6 over x squared plus 5x plus 6. Once again, rational expressions, they are algebraic expressions. Let's see, are they all expressions? Yes, yes, yes. Whose numerator and denominator are polynomials? Do you see polynomials all over the place? Yes. Students, rational expressions, students. Now, in the past, I think in Algebra 1 you were introduced to them, but maybe not full on till this year. Let's go. And we're starting slow. And by the way, if you've been practicing on the warm-ups, you already know half of the stuff that we're going to do today. And that's part of the practice that we put in. All right? So, as you're finishing up writing that, look up. Tell your neighbor why these two are not rational expressions. Tell your neighbor why those are not rational expressions. Why are those not rational expressions? All right. Looks like Luis got it. I see you, Luis. Ezra's got it. I see you, Ezra. Isaac, why are those not rational expressions? Equal sign. They're equations. That is correct. Right now, we're just going to focus on expressions only. So over here, hashtag algebraic expressions, hashtag polynomials in the numerator and denominator. So, talking about rational expressions, ready? Where do we get that from, Q? Here goes. Look up to the screen. If I gave you this definition, let's go. Here we go. The Q stands for Quintanilla. No, it stands for the answer of a division. What is the answer of a division? It is called a quotient. Now, why is it called a quotient? Well, because fractions are division. Does that make sense? All right, so let me read you this solution set here. It reads, rationals are the set of m divided by n. Makes sense so far? Yeah. Where m and n are z's. You're like, what are z's, Mr. Q? Well, z's are integers. That means any number and their opposite. However, look, we're still looking at rationals here. N cannot equal to 0. So what does that mean? That denominator cannot equal to 0. Now, taking you back to elementary, middle school, remember your teacher used to say, we can't divide by 0 because we end up with an undefined. Who remembers that? Some of us? Okay, good. However, now that you are in Algebra 2, the undefined, or that number that makes this denominator 0, is now known as excluded value. That's what we're going to be doing today for half of the lesson, and that's going to be half of your home plate. The second half, you already know how to do it, and I'll show you that in a little bit. So without further ado, here are the steps. You don't need to copy them. They're going to be up there. We're going to go through the process. Step 1, we're going to do excluded values. Step 2 and 3, we've been working on these on the warm-up. You're like, really? Yeah. Problem number 1. Got you guys ready for the lesson? Let's go. Copy this. Example 1, identify the excluded value, then simplify to lowest terms. Write the instructions for this one and the expression 2x over 2x plus 6. Copy that. For the next one after this, you don't have to copy the instructions anymore because you already have them. Here we go. You already copied it, right? All right, writing utensils down, look up to the screen. I'll have you finish copying a little bit. I'll give you more time. Hold on. Going downtown. Have you guys watched that video? She's talking about making my way downtown and talking about walking so many miles, right? And she's on the truck. Wow. All right. I'm going to do the first part, which you haven't done. Look up. We're going to identify excluded values. So on your home plate, some of the problems are just going to ask you, identify the excluded value. How do I do that, Mr. Q? Well, let me show you. I'm going to write it over here. Tell your neighbor what EV stands for? No, it's not electric vehicle. Excluded value. What do I do, Mr. Q? You take the denominator, set it equal to 0, solve, and that is our excluded value. Now, what does that mean, Mr. Q? That means that I can substitute, look up, I can substitute any number in here for x. Doesn't matter what number it is. Except for which one? -3. Why not, Mr. Q? Because what is 2 times -3? -6. What is -6 plus 6? 0. We cannot use that because the denominator cannot be 0. Copy that, please. All right, here goes a recap again. Whenever the question is identify the excluded value, what do? We take the denominator, set it equal to 0, solve for x, and those are going to be our excluded values. Right now we only have one, but we will have more. All right, we're done with the first part. Writing utensils down, look up to the screen. Second part, they want us to simplify to lowest terms. Have we been doing that? Yes, Q. All right, so I'm going to go to step 2, which means factor completely. Look up. This one is already factored, so I'm just going to write it as 2 times x. Can I factor this one? Yes. What's GCF, everyone? 2, and we're left with x plus 3. We're done with step 2. And the last step, identify any giant ones. Do you see any giant ones? Yes. Can we do the x's here also? Tell your neighbor, why not? Why can't we do the x? Because there's what? Addition. We can't do that. So what do we have left? X over x plus 3. Copy that, please. And this is simplified. Have we been doing that on the warm-ups? Yes, Mr. Q, thank you. You're welcome. Gotcha. All right, from 1 to 5, how comfortable are you with these two processes? We got some 4s, 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 5s, okay. So let's see how you do by yourself. Ready? Copy this one. Example 1Q, 6x over 3x plus 9. Once again, you don't need to write the instructions anymore. I want you to find me the excluded value and then to simplify to lowest terms. Go. All right, check with the neighbors, see where they're at. Double check, make sure they got the excluded value already and they're working on simplification by now. All right. We'll go over that. All right, EV, help me out, Daisy. What do I write? And then? (3x equals -9). X equals -3. Hands if you got that for that. That is correct. That's our excluded value. We're done with that part. But now we need to simplify. Factor completely. Pay attention to that. These words. Factor completely. How can I factor 6? Oh, 2 times 3 times x. And then what is GCF for the bottom? 3. We're left with x plus 3. We're done factoring completely. Giant ones, the 3. Anything else? No. So that leaves us with 2x over x plus 3. And have we got that? From 1 to 5, how come are you so far? 4, 4, 4. Yeah. So when it says factor completely, you need to think about what numbers multiply to give us 6. Well, 2 times 3, and then the x is right there. For these that are binomials, you need to think about it in terms of GCF. What is the GCF for these two? It's 3. So if we divide both of these by 3, that leaves us with x. That leaves us with 3. This is something else. Like I said, this is the first part. When they ask you for excluded value, this is the work for that. This second portion is this something else. It's simplification. Why do you what? I'm sorry? Oh, because we're getting ready for what's coming. Creating muscle memory. Oh, yeah. Yeah, these are just like little puzzles that I'm trying to put together in your noodle before we get to functions. I'm totally, look at me, look. Right? No, I'm telling you, guys, I don't know if you guys noticed, all year, week before or days before you get to the lesson, I've been prepping your brain so you can be ready for the lesson. And if you've been doing the practice, go. All right? So, once again, the question was from your colleagues here in the class. They're saying, Mr. Q, so then what are we doing with this blue stuff, Mr. Q? We're just doing the practice for something that's coming up. That's done. We're done. We're good. But can we simplify? Yes. Here's the simplification. There it is. All right, let's move on. Copy this one. Crank it up a little bit. Yeah? Oh, yeah. Copy this. Example 1 super Q. X squared over x squared minus 5x. Ooh-wee. Man. Oh, yeah. Excluded value. Give you a head start. Let's see if your noodle kicks in that muscle memory of what you did for home play. All right, let's see. Help us get started. Jackson, go. What do I write? X squared minus 5x equal to 0. All right. Now, last night, problem number 7 looks something like this, but equal to y. Is that correct? Therefore, since this is not a trinomial, we can't use Power Rangers, but what can we check for? GCF, which is x. That leaves us with x minus 5 equal to 0. So now that we have two factors, what do we write? X equal to 0 and x minus 5 equal to 0. Solve. This one's done. This one, add 5, x equals to 5. How many excluded values do we have now? 2 of them, 0 and 5. That was last night's home play. Yeah, some of y'all that have been absent, you guys need to like either come in and see me so you can catch up or watch those videos. I mean, I don't know what else to say. I'm trying to come up with that application called BAM. I come out right there as AI. BAM. Yeah, 0-5, because that tells me that now there's 2 of them. All right, so we're done with that part. Let's simplify. Here we go. What do we do to simplify? Factor completely. So, how do I rewrite x squared in factored form? X times x. Yes, that is correct. Next, what is GCF for the denominator? X, and that leaves us with x minus 5. Done. Any giant ones? Yes. 1, and that leaves us with x over x minus 5. All right, not bad. A little hiccup, yeah. Let's do another one. Copy this one. Example 1 omega cube. I'm going to have you do that one by yourself. Go. Example 1 omega cube, 2x over x squared plus 7x. 2x over x squared plus 7x. Very similar to the one we just did. Go. And I hope you're gonna last. All right, Malachi, walk us through the excluded value while people share with their neighbors. Share with your neighbor what you got. Really quick. Come on, Malachi. All right, what do I write, Malachi? And then, which is x GCF. We're left with x plus 7 equal to 0. And then, x equal to 0. Solve. This is already solved. Minus 7, x equals negative 7. Our excluded values are 0 and negative 7. Hands if you got that. All right. Simplify. Pass on one, Malachi. Isaac, help me out. What do I write on the numerator? 2 times x. Denominator. X plus 7. Giant ones. The x, and that leaves us with 2 over x plus 7. Hands, if you got that? Let's go. Let's go. Those are too easy. Ready for another one? Oh, yeah. Plenty of time. Copy this one. Example 1 super duper cube. Woo-wee. For this one, I don't want you to check for excluded value. You're like, what? No, let's just simplify. So we don't do this step. I go to this step. All right? We got 6x squared minus 6x over 3x minus 3. All right? Look at this. Tell your neighbor what your brain wants to do with that numerator. What does your brain want to do with that? Yeah, factor out the GCF, right? What is our GCF for these two? 6x. That is correct. And that leaves us with x minus. GCF for the denominator, everyone. 3x minus 1. All right. Not coming out on the video. If you guys missed the announcement, just go to the YouTube channel. All right, look up it, please. Can we factor the 6 out more? Yeah, this is what? 2 times 3. So, giant ones. This one. The 3 over 3. And that leaves us with 2x over nothing or 1, and I'm just going to leave it as 2x. I'll stop right there. Those of you following on YouTube, just put in the practice. Go to the beginning of the video. There's the play sheet. Talk to you guys later. Peace.